it is given, prove that sine square alpha, sine square alpha plus sine square 120 minus alpha plus sine square 120 plus alpha. Now, we know sine A minus B formula. We know sine A plus B formula. So now we can substitute the formula. Say that is, this will be sine square alpha as it is. Now this one we can write sine 120 cos alpha minus cos 120 sine alpha whole square. It's basically sine A minus B formula. Sine A cos B minus cos A sine whole square plus we have sine 120 plus alpha, that is sine A plus B formula, sine A cos B, that is cos alpha here, plus cos A sine B. Okay. Sine A cos B plus cos A sine B formula. This is what we have now. Now we have here A minus B whole square, and this is A plus B whole square. This one you can think as A minus B whole square, and this A plus B whole square. Now, when we have A minus B whole square plus A plus B whole square, we know the formula. So that is 2 times A square plus B square. So we have sine 120 cos alpha whole square plus cos 120 sine alpha whole square. Why is this so? We can write it down as A plus B whole square plus A minus B whole square is what? 2 times A square plus B square. Now this gives us sine square alpha plus 2 into, now sine 120, what is sine 120? Now we can find it separately also. Sine 120 can be written as sine 2 into 90 minus 60. 2 means sine will be remaining as sine 60. Now this is in which quadrant? 120. You can think in this way that we have here 90 and 90, because this is plus and minus 60, that means returning back to the second quadrant. Returning back to the second quadrant. Second quadrant, whenever some angle is there in the second quadrant, we know when sine is applied, this is positive. So here sine 120 will give us some positive value, that is root 3 by 2. Even if someone is doing this sum, but doing this sum that time, if someone is not seeing about the sign, no problem. Why no problem? Because it's square thing is given. Now this will be what? 3 by 4 cos square alpha plus, now cos 120. Cos 120, what we can write? We can write this one as cos 2 into 90 minus 60. Second quadrant, so this will be what? Minus cos 60. So this is minus half. Now this gives us what? It is 1 by 4 sine square alpha. Now from this, if we simplify this one, 2 into 1 by 4, that will be half. So this will be sine square alpha plus 1 by 2 sine square alpha plus 3 by 2 cos square alpha. Because 3 by 4 into 2, that is 3 by 2. 1 plus half, that is again 3 by 2. So this is 3 by 2 sine square alpha plus 3 by 2 cos square alpha. Now here 3 by 2 into sine square alpha plus cos square alpha. And that gives us 3 by 2 into 1, which is 3 by 2. Why 1? Because sine square alpha plus cos square alpha will give us 1. So hence answer is 3 by 2, which is the required. sine square pi by 8 plus theta by 2 minus sine square pi by 8 minus theta by 2 is given, and we have to prove that this whole expression is equal to 1 by root 2 sine theta. Now this one, this expression is exactly of the form of sine square A minus sine square B. Why? We can think this one as A and this one as B. So this exactly with related to in accordance with the formula sine square A minus sine square B, which is sine A plus B into sine A minus B. Now from this what we can see that we apply this A plus B to A minus B. So what we get, it is pi by 2 plus theta by 2 plus pi by 8 minus theta by 2 into sine pi by 8 plus theta by 2 minus pi by 8 plus theta by 2. This gives us sine pi by 4 into sine theta. So that will be 1 by root 2 sine theta. Sine pi by 4 is 1 by root 2 equal into sine theta. And that is the RHS part. We have started the LHS part and we got the RHS part in school. Cos square A plus cos square A plus pi by 3 plus cos square A minus pi by 3. We have to show or we have to prove this is equal to 3 by 2. It is cos square A plus cos A cos pi by 3 minus sin A sin pi by 3 whole square plus cos A cos pi by 3. Now see, this is a fourth form. This is A minus B whole square plus A plus B whole square. Now this we take as A, this we take as B. So this is A, this is B. So this is A minus B whole square, A plus B whole square. So what we can write here? Cos A cos pi by 3 whole square plus sin A sin pi by 3 whole square. This is cos square A plus 2 into cos square A. Now cos pi by 3 is what? 1 by 2. So it's 1 by 4 plus sine square A into 3 by 4. Now this gives us what? Cos square A plus 1 by 2 cos square A plus 3 by 2 sine square A. This gives us 3 by 2 cos square A, because here 1 plus half cos square A, that will be what? 3 by 2 cos square A plus 3 by 2 sine square A. Now we take here 3 by 2 common and we get cos square A plus sine square A, and that gives us 3 by 2. Tan 70 equal to, which we have proved is tan 20 plus 2 tan 50. This is what we need to prove. The relation between the angle you have to find. So the same concept, that 20 plus 15 equal to 70. Tan 20 plus 15 equal to tan 70. That is tan A plus B equal to this one. Now tan A plus tan by 1 minus tan A tan equal to tan 70. Okay. Tan A plus tan B by 1 minus tan A tan B equal to tan 70. Now cross multiply. Now tan 20 plus tan 15 equal to tan 70 minus tan 20 tan 70 tan 50. Okay. Now this is what? Tan 20 tan 70 tan 50. Now here what will happen? Observe carefully. So always whenever you have theta plus alpha equal to 90, just you do this one. Alpha equal to 90 minus theta. This will keep in mind. Now tan alpha equal to tan of 90 minus theta. So that is what? That is cot theta. And that is 1 by tan theta. So always we keep this in mind, that if you have sum of the two angle is 90, then the product of the tan is 1. So whenever it is there in the sum, you can utilize this technique. So that is 1. And once you have done that, you can write tan 20 plus twice tan 50 equal to tan 70. A plus B equal to pi by 2 or 3 pi by 2. If you have, because here you have with 70, 20, suppose in the question they have given some other value. They can give you, no issues. If A plus B is 20, pi by 2, 90 or 3 pi by 2, always what you'll get, you will get this one. Tan A minus tan B equal to 2 times tan A minus B. But here we are understanding it another technique here, another shortcut technique here. That by seeing this sum, how can we say the answer, or how can we say that what will be the result? A plus B, here A is this one, B is this one. If A plus B is 90 degree or 3 pi by 2, always this is true. Because in MCQ sometimes they give you to find the lambda. They give this one lambda and tell you to find. So always this will be true. You see, A is 70, B is 20, then you get this one. You might say, well, how is this coming that I'm showing? So this, if you can keep a note, this is a shortcut method. Now here, A plus B is pi by 2. So A plus B equal to, so what we can say, that A equal to pi by 2. Okay. So from this what we can say, tan equal to tan pi by 2. Because it is pi by 2 minus B means first quadrant everything is positive. So tan A into tan B equal to 1. Now you can find tan A minus B very easily. Tan A minus B equal to, so tan A minus tan B by 1 plus tan A tan B, and you see your tan. Because tan A tan B is, this part is 1, so this is becoming 2. So it is tan A minus tan B by 2. So if you cross multiply, you are getting this. So this is a very nice technique. Cosine, sine plus cos B sine C minus C plus cos C sine A minus B. You have to simplify this one. Very simple. That is just this expression is given, and we have to simplify. Now, how to simplify here? We can understand here that we can use here sin a minus b formula. These are the form of a minus b. So we can write here cos a sin b cos c cos b sin c. Next, cos b into sin c minus c. Sin c minus c, we know the formula. That is sin c cos a minus cos c sin a plus cos c sin a minus b, that is sin a cos b minus cos a sin b. This is what we get. Now, after that, what we do is simply multiply and try to check what we are getting. We try to simplify basically. So this is sin b cos a cos c cos a cos b sin c plus next cos b, here cos a cos b sin c. So we can write here cos a cos b sin c. Next one sin a cos b cos c. So minus sin cos b cos c. Then plus sin a cos b cos c. So sin a cos b cos c minus cos a sin b cos c. Just we are multiplying this with this one. Now what we can understand this and this is getting cancelled out, and lastly this and this is cancelled. So the result is very simple sum, just the application of the formulas. One plus sin a minus b by cos a cos b plus sin b minus c by cos b cos c plus sin c minus c divided by cos c cos a. That is also formula based sum. This sin a minus b formula we know, sin b minus c formula we know, sin c minus a formula we know. So you can just substitute it here. It is 1 plus sin a cos b minus cos a sin b whole divided by cos a cos b plus sin b minus c sin b cos c minus cos b sin c whole divided by cos b cos c plus sin c cos a minus cos a sin c whole divided by cos c cos c. Just we have after the formula here sin c minus a, that is sin c cos a minus cos a sin c. Now very simple, we'll divide this by this and this by this, then this by this minus this by this by this minus this by this. So what we write here? 1 plus sin a cos b whole divided by cos a cos b minus cos a sin b by cos a cos b plus sin b cos c by cos b cos c minus cos b sin c by cos b cos c plus sine C cos A by cos C cos A minus cos A sine C by cos A cos C. Now you can understand here that here cos B cos B cancel out. Here cos A cancel out. Here cos C cancel out. Here cos B cancel out. This is cos A, this is cos A cancel out. Here also this one and this one cancels out. So what we get here? Sin A by cos A, that will be tan A. Sin B by cos B, that will be tan B. This is also tan B. This is tan C. This is tan C, and this is tan C. So tan A, tan B, tan B, tan C here. Here what we get? Tan C. Here also we get tan C. So ultimately this is 1 plus tan A minus tan B plus tan B minus tan C plus tan C cos C sine. So this gives us minus tan. Hence the result is 1 because the rest of the terms will get cancelled. Tan pi by 4 plus theta into tan 3 pi by 4 plus theta. Now this can be written as tan A plus tan B by 1 minus tan A tan B into tan A plus tan B divided by 1 minus tan A tan B. Tan pi is 1, so 1 plus tan theta by 1 minus tan theta into tan 3 pi of 4 minus 1 plus tan theta by 1 minus of minus 1 tan theta as tan 3 pi by 4 equal to minus 1. You can see this one. How tan 3 by 4 is minus 1. Tan 3 pi by 4 can be written as pi minus pi by 4. That is 2 into pi by 4. Now 2 means tan will be remaining as tan. So tan pi by 4. Now there is a minus in front. Why? Because if we take the quadrants, then we can understand this lie in the second quadrant. Why second quadrant? Pi by 2 minus something. So the angle dimension is second quadrant. Second quadrant tan is negative. So what we get? Minus 1. Minus tan pi of 4, which is minus 1. So this is what we get. Now A plus B into A minus B. That will be what? A square minus B square. So tan square theta minus 1 divided. This will be plus. So A minus B into A plus B. So that is giving us A square minus B square. We take minus and common from the numerator. So it is 1 minus tan square theta by 1 minus tan square theta, which gives us minus 1, provided 1 minus tan square theta not equal to 0. And this is assuming we come to the conclusion that whole expression gives us minus 1. Sine d plus c into sine b minus c plus sine c plus a into sine c minus c plus sine a plus b into sine a minus b. We have to simplify this. Now, this is simply based on the formula sine a plus b into sine a minus b, that is sine square a minus sine square a. So we apply this formula in the first part, second part, and third part respectively. So sine square b minus sine square c plus sine square c minus sine square a plus sine square a minus sine square b. Now this cancels out, this one cancels out, this one cancels out. So this add up to 0. Sine a minus b plus c. Now what we try to make it a minus b as one angle and c as the other angle. And then we'll have to explain the other one. That is the technique here. That is, this is sine of a minus b plus, so that is sine a plus b formula, that is sine a cos b plus cos a sine b. Now sine a minus b, we can simply expand this one, that is sine a cos b minus cos a sine b into cos c plus cos a sine cos a cos b plus sine a sine b into sine c. Now if we multiply this, we get the required result sine a cos b into cos c minus cos a sine b into cos c plus cos a cos b cos c sine c plus sine a sine b sine c. So basically very simple sum. Just you have applied the formula here, sine a minus b formula, here cos a minus b formula, and then we have determined the value for the required result. Tan a plus b minus c. Now here also the concept will be same. That is, here what we get, tan, we can take it as a plus b as one angle minus. So that will give us tan a plus b formula, a minus b formula, because here you can see tan a minus b. This whole thing you take as a, this whole thing you take as b. So it is tan a minus b formula. That is what? Tan a minus tan b. You think this as b. So tan a minus tan b by 1 plus tan a plus b tan c. Now this gives us tan a plus tan b by 1 minus tan a tan b minus tan c by 1 plus tan A tan B, tan A plus tan B by 1 minus tan A tan B into tan C. So what we have done is tan A plus B, tan A plus tan by 1 minus tan A tan B minus tan C. Here tan A plus B, that is 1 plus tan A plus tan B by 1 minus tan A tan B into tan C. Now after that we can simplify. So what we get here, it is 1 minus tan A tan B as LC. So we get tan A plus tan B minus tan C plus tan A tan B tan C divided by same LCM children, 1 minus tan A tan B. Now if we multiply here, what we get, 1 minus tan A tan B plus tan A tan C and plus tan B tan C. Now if we simplify, just a matter of 1 by tan A plus tan B minus tan C plus tan A tan B tan C by 1 minus tan A tan B tan B tan C tan A tan C. That is the last line which we get after simplification is tan A plus tan B minus tan C plus tan A tan B tan C whole divided by 1 minus tan A tan B plus tan B tan C plus tan C tan B. That's it. Sin alpha sin beta minus cos alpha cos beta plus 1 equal to 0 given. And what we have to show that sin alpha plus beta equal to 0. And that is, first of all, we have to show here sin alpha plus beta equal to 0, and hence from that means after we prove this one, using that result we have to show 1 plus cot alpha tan beta equal to 0. Now when this is given, it is given what from the given expression, what we write, this is sin alpha sin beta minus cos alpha cos beta equal to minus 1. We multiply throughout by a minus 1. So cos alpha cos beta minus sin alpha sin beta equal to 1. Now this gives us cos of alpha plus beta equal to 1. Now we know sin square alpha plus beta plus cos square alpha plus beta equal to 1. Now if we substitute the value of cos alpha plus beta as 1, what we get? This implies that sin square alpha plus beta equal to 0. And this implies sin alpha plus beta equal to 0. Now, this is a pretty simple one. Just we have got cos alpha plus beta and then from that sin alpha plus beta. Now, hence reduce means by using this only we have to come to this conclusion. There is cot alpha plus cot alpha, 1 plus cot alpha tan beta equal to 0. How? Simply split up this one. Since we have been told hence reduce, that means from this one we have to come to this one. We'll simplify this one. That means we'll expand this one by following the formula. This sine alpha cos beta plus cos alpha sine beta equal to 0. Now after this we need cot alpha. So we divide throughout by sine alpha. If you divide by sine alpha, what will become cot alpha? Now you need tan beta also. So divide by cos beta. So by what will divide? Dividing throughout by sine alpha cos beta. So that gives us what? Sine alpha cos beta by sine alpha cos beta plus cos alpha sine beta by sine alpha cos beta equal to 0. Now this gives us what? That this is 1 and this is cot alpha tan. So it is 1 plus cot alpha tan beta equal to 0. So that we have deduced from this expression.